Hi guys, this video is just to give you an explanation as to where the compound angle formulas come from. It's a pretty interesting process using some geometry that is not unreachable, but this you will not be required to reproduce this on a test or anything like that. It's more so of just an explanation, so you don't just have to take it at face value. It works, so use it. Kind of explanation. It does work, and here's why. So here's our unit circle, and we're going to build two triangles on it. In standard position. So one is going to be, let's do right over here, all the way to the edge there. And this one's going to have a central angle we'll call A. Okay, so this length down here, just like we know, because this point is cos A sine A, so that tells us that this length here is the cos of A, and this length here is the sine of A. And if I were to do this again with another angle, let's call it B, and I would take B and rotate it so that its bottom, known as the cos of B, lines up with the hypotenuse of this triangle. What it might look like is something like this. There's the right angle, there's the hypotenuse, it'll still be a length 1. And this guy would have a length here that is the cos of B, that's angle B here. And this guy here would have a length of the sine of B. Okay. Now, if what I'm going to do is I'm actually going to take this, see this intersection point right here where the base of the sine of B hits the hypotenuse. I'm going to draw a line through there, and that line is going to be perpendicular to the x-axis. I'm just going to do that there. You'll notice I've created a little triangle inside there. And then I'm going to draw another line that's parallel to the x-axis that connects to this point right here where the hypotenuse of B touches the circle, and it connects back to my other line and creates a second triangle in here. So you'll know. So let's just call this. So what we could do is we can actually use some basic geometry. If you want, you can figure it out yourself, or you can just trust that it's true. But what we'll find out is that the angle inside this little triangle here is actually A. Feel free to figure that one out and show it to me, but I'm not going to go into it now. I'm just going to call this triangle triangle 1, and this one down here triangle 2, and we're going to take a closer look at each of those triangles. So here we go. Triangle 1 is right angle triangle. There's a weird looking right angle triangle, and this is angle A, and its hypotenuse, if you take a close look at triangle 1 up here, you can actually see is the sine of B. So I'm going to label that sine of B. Okay, now, if I were to try and figure out what this opposite side here is and what this adjacent side here is, I would use the cos and sine formulas for A. So the cos of A is going to be equal to the adjacent side over the hypotenuse. And as we can see from the diagram, the hypotenuse is the sine of B. So solving for the adjacent side, I get that the adjacent side is equal to cos A times sine B. And I'm going to do this again for the sine of A, which is the opposite side over the hypotenuse. And again, hypotenuse is the sine of B. So the opposite side is equal to sine A sine B. We're just going to leave that there for now. And we are going to look at triangle number 2. So triangle number 2, let's set it up, also happens to have angle A. It's not the same triangle. It's clearly a different size based on our original diagram. Its hypotenuse is the cos of B. You can see that right over here. That's actually, we built it up that way, so B is sitting right on top of the hypotenuse, and that's where we cut it off. So that's where the smaller triangle here gets its hypotenuse is the cos of B. Okay, so now the cos of A in this case is going to be equal to still the adjacent over the hypotenuse, where the adjacent is here and the opposite side is here. And the hypotenuse in this case is the cos of B. So the adjacent side is going to be equal to cos A cos B. And I'm going to do it again for sine of A, and that's going to be equal to the opposite side over the hypotenuse. And solving for the opposite side, I get, oh, remember, hypotenuse is still cos B, so multiply that up, and I get opposite side is sine A cos B. Okay, so now we have all the tools we need, and we'll take a second look at our unit circle diagram so we can sort of see what we're doing. And if you take a close look, if we were to trying to find the cosine sine of A plus B, that's this whole angle in here from the base all the way up to the hypotenuse of our rotated triangle, that would have us look at this point right there. And so we can actually piece together all these different properties that we've just looked at to find its x and y coordinate. So for example, its x coordinate, draw a dotted line all the way down here, is this distance right there. That's the cos of A plus B. Cos of A plus B in brackets. And the sine of A plus B is this total distance here. So that's the sine of A plus B. So if you take a close look, looking at triangle 1, we can actually see that right over here, this is the same as the adjacent side on triangle 1. So this distance in here, this distance right here, is the adjacent side, which is, let's just call it adjacent 1. And the rest of this distance here is the opposite side of triangle 2. Similarly, we can see that the full length here, the adjacent side of triangle 2 covers all that distance. It's the adjacent side of triangle 2. And we can look right in here and we can see this little length right in there. That's this guy right here. It's actually the difference between these two lengths. And that is the opposite side of triangle 1. So what we were actually left with is that cos of A plus B is adjacent of 2 minus opposite 1. So let's write that out using what they're worth. The cos of A plus B is equal to adjacent 2 minus opposite 1. And looking at those values, adjacent for triangle 2 is cos A, cos B. Opposite 1 is sine A, sine B. And there's our first identity for the cos of A plus B. And then doing something similar up over here, we can see that the sine of A plus B is adjacent 1 plus opposite 2. So the sine of A plus B is equal to adjacent 1 plus opposite 2, which is adjacent 1 is cos A sine B, and opposite 2 is sine A cos B. And there we have it. There's our two main compound angle formulas. And then for the subtraction ones, we would treat B like it's a negative angle, and it just sort of adjusts it based on what we were talking about in yesterday's lesson with the half angle formulas and the equivalent trigonometric expressions. But that is the ultimate origin of where these two properties come from. I'm not going to bother to show you the cos A minus B or the sine A minus B, but you can extrapolate yourself where those might have come from. And that's it for this video. Thanks, guys.